Push that rock with Simpson Math. Is your PIN a number? Well, it's got the word number in it, so, and it uses digits. Maybe this is your PIN. So it must be a number, right? Well, no, it's not a number. What it is a string of digits used as a name. It's like some rock star gave their kid a name. I'm gonna name my kid 8012. That wouldn't be a number, that'd be the kid's name. Here's your test. Divide it by 2. Divide your personal identification number by 2. What do you get? In this case, if your PIN is 8012, you get 4006. Now what is this? This isn't half of something. It's not half the distance. It's not half as much gas. It's not half as many apples. This is a number you can't use. It's maybe somebody else's PIN, but it's not the PIN of somebody that's half as important as you, or half as tall as you, or half as anything as you. It's just some random other string of digits, and it means nothing. So that means when you cut it in half and it means nothing, it means that your PIN is not actually a number. In statistics, what we call it is a nominal level of measurement. Sometimes we assign digits instead of letters to a name because digits have uses. Like, for instance, books have identification numbers. And those identification numbers use the digits to help classify the type of book it is and do other things. Credit cards have strings of digits on them, and the credit card machines can use those digits to do some math behind the scenes. But that math has nothing to do with the number itself. It has to do with just the sequence of digits and matching that sequence of distance with the user or the bank account or whatever. So in statistics, sometimes we assign, and in life, we sometimes assign numbers to a category or a name, and that's called nominal level of measurement. And it confuses people. They think, oh, it's got numbers, it must be a number. The 4 levels of measurement are nominal, ordinal, interval, and ratio. With nominal, no math is possible. Okay, makes sense. I mean, we use the digits and we do some math behind the scenes. Maybe that's why we assign the number, but you can't do any math with your personal identification number or anything that's on the nominal level of measurement, like doubling it or adding it or subtracting. You can't add 2 pins and get more access, or subtract 2 pins and get less access. So with nominal level of measurement, no math makes sense. Okay. With the ordinal level of measurement, only order makes sense. 1 would be smaller than 2. 10 would be greater than 5, but that's it. We don't know that 10 is twice as big as 5 if it's on an ordinal level of measurement. With the interval level of measurement, you can do subtraction, but not division. And with ratio level of measurement, all math is okay. You can do any math that you're used to. So let's do a couple examples. So at the ordinal level of measurement, those are those scales, like when you evaluate this class on a scale of 1 to 5. How well did the teacher explain the levels of measurement? Okay, well, that's an ordinal level of measurement. If you think I did great, you might give me a 5. If you think I did great, you might give me a 4. The person that gave me a 5 and the person that gave me a 4, it doesn't mean that that person thinks the 5 thinks I'm 1 slot better than the 4. Maybe that's just one person never gives out 5s. 4 is the top-notch teacher. He gives a 4. Somebody could give me a 2. It doesn't mean that the 4 thinks I'm twice as good as the person that gave me the 2. Maybe the guy that gave me the 2 thinks I'm his favorite teacher, but in that category, he's rating me low because that's something I'm weak at. So with the ordinal level of measurement, it's like place values in a tournament. Let's say we have a tournament and the place that you get depends on how many targets you hit. And this player hit 10 targets and nobody else hit 10 targets, so he gets first place. The second place player hit 8. He did pretty good. He didn't do as good as first, so he gets second. And then the third place he hit 5 targets and everybody else hit 4 or fewer targets. So clearly this guy's the best. He hit the most targets, 10. But did he hit twice as many as the second place. See, 2 is twice as big as 1. He didn't hit twice as many. So see the math of saying, oh, well, 2 is twice as big, so I can assume that the first place guy hit twice as many as the second place. No, you can't assume that. Math makes no sense with this ordinal level. All you know is that if you don't have this information, all you know is that the first place guy hit more targets than the second. That's all you know. You don't know that he hit one more. You don't know that he hit twice as many more. You just know he hit more. And second place target hit more than third, and third hit more than everybody else, unless there was a tie maybe. So that's all you know. So you only know order. That's ordinal level of measurement. In the ordinal level of measurement, you only know order. This is an example of interval level of measurement. In interval, there's no true zero. No true zero in interval level of measurement. So there's 3 ways, that I know of, to measure temperature: Fahrenheit and Celsius and Kelvin. Kelvin, there is a true zero. Zero means no temperature, no actual activity of the molecules at all. Okay, but with Fahrenheit and Celsius temperatures, it was the scales we're used to. Those are called interval level scales because there's no true zero. We use 0 on the Celsius scale to mark where water freezes at sea level. And we use 32 to mark where, on Fahrenheit scale, to mark where water freezes at sea level. But that doesn't mean that it doesn't mean that there's no temperature. And when water is freezing, that doesn't mean there's no temperature. There's still a temperature. There's still molecular activity creating some warmth, just not as much warmth as when water's not freezing. And the same here. I mean, we got to go further down to get to the 0. But there are things that freeze at below 0. So that means that there's still some temperature at 0. So there's no true 0. And for that reason, you can't say that 20 degrees Celsius is twice 10 degrees Celsius. It doesn't make any sense. You can do subtraction. You can say 20 degrees 0 is 10 degrees higher than 10. That does make sense here, whereas it did not make an ordinal. Over here, you can't say 2 is 1, or first place is 1 better than second. It's 1 place better, but it doesn't mean that what we're measuring was 1 better. Here you can do subtraction, but you cannot do division. So I can't go 20 divided by 10 is 2, therefore 20 is twice as big as 10. Yes, the number 20 is twice as big as 10, but the temperature 20 degrees Celsius is not twice as warm as the temperature 10 degrees Celsius, if that makes any sense. And finally, there's ratio. That's the usual use of numbers as in math class. Most things are measured on a ratio level. If I'm counting the number of children families have in the household, that's ratio, even though it's discrete. 4 children is twice as many as 2. 0 children is 0 children. So, or if I'm measuring lengths or weights or volumes, all that will be on a ratio level of measurement. So ratio is the normal level of measurement. Interval is a scale where division doesn't make sense and there's no true 0. Ordinal is just where you put an order to things like cleanliness or maybe your pain. Remember the pain scale when you go to the doctor? What's your pain on a scale of 1 to 10? Okay, so you just provide an order. He knows that a 10 is more pain than an 8. So if you tell him 10 now and then an hour after you take the ibuprofen, you say 8, he knows the ibuprofen's working a little. And then nominal is when we use a number for a name. Math made simple. Simple math.